S. Chan presents Educational Video Lectures. Difficult concepts made easy. Study anywhere, anytime.
How the information transfer from one place to another place. How the signals that are transferred. So that signals that can be transferred in the form of analoging digital circuiting is used. So analog signals are that in which there is some noise ratio is there. But when we want to transfer the signals in a simplest form, the digital things are done over there. So digital signal process is done. So firstly, we will understand what are the analog signals and what are the digital signals.
If you want to study this topic in detail, refer to the book by S. Chan Publishing. Link is provided in the description box.
So myself, Dr. Narendra Kaur. Now welcome to S. Chan Academy. So let us begin how we can transfer our knowledge from one place to another place in the form of signals. So now what are the analog signals? So analog signals, these are used in the many systems to produce signals and they can carry the information. That means when we want the information from one place to another place and how the information or that can be carried in the form of signals. So these are the analog signals. In the simplest way, when there is nothing is there, simply we can in the natural way the information that is transferred from one place to another place. So such kind of signals, they are known as the analog signals. So that means these signals are continuous in both value and time. The use of analog signals has declined with the arrival of digital signals, because when there comes a digital word, so information in the digital signals that is in the form of steps, not continuous values are provided in that case. Because when we are, for example, when we are continuously hearing the songs by putting earbuds in our ears, so after some time we are feeling some pain. So that is because the analog signals transfer their energy as it is from one place to another place. But when we want the signals or the information that is transferred in the easy way, or you can say that in the energy that is tuned with respect to the receiver. So that is done in the form of digital signals. So now the analog signals therefore be used in many systems like to produce signals. They can carry the information and they are continuous. For example, when we are dealing with the analog signals with time, so there is a continuous rise and continuous decline in the signal processes there. So analog signals, there is a continuous information transfer from one place to another place. And in short, we can say that to understand analog signals or signals that are natural or come naturally, they are known as the analog signals. Now what are the digital signals? Here, unlike analog signals, digital signals are not continuous, but signals are discrete in value and time. So now you can clearly see that here there is a discrete value. Discrete values means these are the discontinuous. So information here that will remain constant for some time, then after that increased. So that means in the step size we can transfer information from one place to another place. So unlike analog signals, digital signals are not continuous, but signals are discrete in value and time. These signals are represented by binary numbers and they consist of different voltage value. So what binary numbers are used over here? So that means in this case, either there is on, if the voltage is on, so it will give us output value as 1. Now if there is off, nothing is there, then the output value that will be 0. So binary numbers are used here in order to describe the output value, and they at the different voltage values are also given over here. That means the voltage that can be tuned, so information that can be carried from one place to another place. So analog signals, these are the continuous signal over here. So with time, so these signals are continuous. There is no discreteness or no discontinuity is there. But in the digital signal, so these signals are discontinuous with the time. So that means after some time we will get the output, and then after some time there is no output. That means these signals here, there is a gap over here. So there it will form a bridge between the output and the input signal. So these signals they are discrete or the discontinuous value. And when output is there, we will get 1 over here, and when there is no output, so 0 will be there. So that means now again at this value there is output, here is 1, in between there is no value, so 0 will be there. So that means these are known as a Boolean numbers or the binary number. This is also known as the Boolean algebra in order to represent the output via the digital signals. Okay, now next is what is the difference between analog and digital signals. So analog signals are what? They are continuous signals, and digital signals, they are discrete signals. Now they can be represented by the sine waves and they can be represented by the square waves. So does it mean that means we know that the sine waves, these are the continuous wave. So output from the analog signals that can be represented like this. So these are the analog signals. So this is also known as sine wave or the cosine waves, because sine wave as well as cosine waves, these are the continuous wave. Why? So this is for the analog signals, because they are continuous, no discontinuity is there, and that will be represented up to infinity time. Now for the digital signals, they are represented with the square waves. So what is the meaning of square wave? Means like this. So these are the square waves, or you can clearly see that the digital signals can also be represented like this. So these are the step-like system is there. So these are the representation of the digital signals, or the step output is there. So this is the representation of the digital signals. So then these are represented by the sine wave, they are represented by the square waves of the step waves. Then now what are the examples in this case? These are the human voice, because it comes continuously over there. So there is no break. So that's why human voice, the natural sound, the analog electronic devices, these are the few examples of the analog signals. While the computers, optical drives and the other electronic devices, or you can say that the digital clocks, all these are the examples of the digital signals. And there is a continuous range of values, because the output is continuous, so there is no discontinuity. So from beginning to end we are getting the output value. So that's why they gives us the continuous range of values, while digital signals, they gives us only the discontinuity values, because in between we know that here the binary numbers that represent their output. So either it is 0 or either it is 1. So due to that, the output value, that will be the continuity will be there, because the step-like functions are there. So when there is a step, so there is like this. So due to this step-like values, so in between there is a discontinuity is there. Again there is a discontinuity. So value is continuous for this period only. So here the output is value is 1, while in between this value it will be 0. Again output is value is 1 over here. So due to discontinuity in the output signal, so they give us only the discontinuity values, and record sound waves as they are, because there is no continuous signals are obtained. So the input value and output value, they are having the same energy range over here. So that means they will record the sound waves as they are. So originality is maintained in this case. While in this case, they will convert into the binary waveform. Because why they convert into the binary waveform? Because the signals are converted by the Boolean algebra, and we are getting only in the binary numbers we are getting only output. So either the output value is 0 or 1 over there. So that's why in the digital signals, the output is converted into the binary waveform. But here in this case, only the sound waves which are recorded and their energy and the input values are maintained same throughout. So there is no discontinuities there, and only that is used in the analog devices, and digital signals they use for the digital electronics like computers, mobiles and more. Now what is why we go from, if analog signals gives us the continuous signals, then why we go from analog to digital signals? So the major jump is from analog to digital is there is a large number of noise pollution is there, and due to that, due to noise pollution, the efficiency of this devices that is get reduced. So that's why we are going to opt from analog to the digital signals. That means in the digital signals only there is two outputs are there, either that will be 1 or 0. So due to that, the noise in the signals that is reduced. While in analog signals, as the input and output both are having the same energy values. If there is noise in the originality, in the natural sound, if there is a noise, that noise is maintained up to the output signals. That means we are hearing the same noise as the output signal. So in order to remove that noise and in order to enhance the efficiency of the device, we are opting or we are moving from analog to the digital signals. So due to discontinuity values and due to discreteness in the values, we are getting the output which is noise free. So that's why the efficiency of the devices or the energy of the devices that can be enhanced. So our system is now using the Boolean algebras and we are moving from analog to the digital signals. Okay, so Boolean algebra, that is a category of the algebra in which variables values are the truth values, and that will give us a true or false. That means in order to convert analog signals to the digital signals, we are opting by Boolean algebra, and that gives us either true value or the false value. That means in this case it is either yes or no. When it is yes or the true, it will give us the value 1. When it is false, then it will give us the value 0 is there. So that means Boolean algebra, that is a category of algebra in which variables values are the truth values. True or false, ordinary, that is denoted by 1 and 0 respectively. Now they are used to basically where it is used. So Boolean algebra, they are used to analyze the digital circuits or the digital gates. So that means in this case, in order to convert the analog signals to the digital signals, we are using this Boolean algebra by using the different logic gates. They are used over here. So digital circuits or the digital gates, they are get simplified or they can be analyzed by using this algebra. This is also called Boolean algebra or the logical algebra because it gives us only two values, either it is 1 or 0. So logical output is there, so that's why they are also known as logical algebra. And it has been fundamental in the development of digital electronics, and it will provided for all the modern programming languages, because also the programming languages are based upon the mathematical terms, and the Boolean algebra gives us the output either 1 and 0 in the mathematical terms. So that's why this is used in order to solve all the problems in the day-to-day life, and they can be implemented in the programming languages also. And it is also used in the set theory and the statics. That means here the Boolean algebra is get used by which we can reduce the noise, and the analog signals, they can be get converted into the digital signals. So Boolean algebra, so that is also called the logical algebra, because in the logics are there, output is either there is 1 or 0. So nothing is in between there. So when we are getting the output, that means if the output is there, then we are getting the 1 value. When there is no output, that means we are getting the 0 value is there. So that's why that is also used in the mathematical terms, that is in set theory and the statics. So different statistics are also implemented. For example, when we are implementing the FD statics, that is known as a Fermi-Dirac statics. So according to that, when the electron is present in between the different energy values or energy cells, that will give us the 1 value. When the electron is not present in the different energy cells, then it will give us the 0 value. So it is used in the set theory and the statics in order to solve the many problems. So that can be solved over here. So now let us take a short break. So after that we will continue the different types of the logic gates and how the Boolean algebra is used to convert the signals, analog signals to the digital signals.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back to S. Chand Academy. So now let us begin with this Boolean algebra, how we can convert the analog signals to the digital signals. So now we know that with the Boolean signals or with the Boolean algebra, that is a category of algebra in which it will give us only the true value or the false value. So when it gives us the true value, that means that is denoted by the 1, and when the value is false, that is denoted by the 0. So that means when we are getting the output is there, So the digital signals with the time, and there is a signal. So we know that when the analog signal is there, so we are getting the continuous output is there. So due to this continuous output, the noise ratio that is quite high. That is very high. So due to this high noise ratio, efficiency of the device that is reduced. So in order to enhance the efficiency of the device, we convert this continuous signal into the discontinuous signal. So how that can be converted? So the continuous signals, they can be converted into the discontinuous signal. So in order to convert the continuous signal, and the signal is there, like this, we are getting the output is there. So that means now here the output is there. So we are getting 1. When there is no output, we are getting 0 over here, 1 and 0. So that means the discontinuity is there. So due to discontinuity in the input signal, the noise ratio that is reduced. So now when the noise ratio is reduced in the input, automatically the efficiency of the output that can be enhanced. So efficiency that can be enhanced. Now what is this 1 0 1 0? 1 0 1 0, that means it is basically a Boolean algebra. Why the term algebra is used over here? Because these are the mathematical terms. So that's why this is known as the algebra. Or 1 means the output is there. So output is non-zero. Output is present. 0 means there is no output. So when the signal, continuous signals are converted into discontinuous signal, or you can say that the analog signals, they are converted into digital signal. So such kind of, now the converter which is used over here, this converter which is used, that is known as Boolean algebra, or you can say that that is known as a binary system. Now why this is known as binary system? Because only 2 terminologies are used. So what are the 2 terminologies? These are either true or false. So that means either this is true or false, or you can say that either 1 or 0. So 2 terms are used over there. So that's why this is known as a binary system or the Boolean algebra. I see. The term is used over here. Now next, what are the different terminologies which are used in the Boolean algebra? So Boolean algebra, that is a branch of algebra that deals with the logical operations and the binary variables. Only 2 variables are there. So logical operations, what are the logical operations are there over here? So these logical operations are like when the 2 inputs are used, if 1 A and B, these are the 2 inputs. Or you can say that if T, that is for true, and F, that is for false, then the logical operations are like, they can be, logical operations are 4 or multiply. So these are the logical operations which are used in these 2 systems. Or by using this 4 logical operations in the given output values or the binary systems, we can use or we can develop the logical gates by which the signals are, we are getting the proper noise-free signals, or the digital signals are getting over there. We will get the digital signals. So these are known as the logical operations. Either the output values or the input values which are given over there, we can give output value that is obtained in the terms of digital signals by applying the logical operations, either plus, minus, division or the multiplication. Now what are the Boolean variables? The Boolean variables, that is defined as the variables or the symbols which is defined as the, generally these are known as represented by the alphabets, or values are given as 0 or 1. What are the alphabets? Like means when there is a 0, we can say that that is F, which is false, and 1 is there, that is known as a T, that is for true. So either we can use the alphabets or the mathematical quantities, either 0 or 1, that can be used. So these are known as the Boolean variables. So Boolean variables are the Either they are t or f, these are the Boolean variables, or 1 and 0. So these two are known as the Boolean variables. That means the whole input value that can be used in terms of 1 and 0. So when the whole input values, they are used in the only two terminologies, the noise value that can be reduced. Next is the Boolean functions. So Boolean functions, these are known as the Boolean variables, logical operators, constant 0 and 1. Or operators, what are the operators like? These two values, for example, if A and B, these are the two variables over here. So we can know when, that means when A and B, these are the two operators. So in the first case, we can use these, we can sum of these two signals. Second, these two signals, they can overlap with each other with opposite phase. Multiplication of these signals, that can be done. And fourth one, the division of these signals, that can be done over here. The signals that can be divided over here. So these are known as the logical operations which are applied between the two input signals or between the two Boolean variables. Next are the complement. So the complement is defined as the inverse of a variable and which is represented by bar over the variables. That means when we want to represent inverse of a variable, so inverse of any variable, in mathematical terms, we are representing inverse like this. So that means that is 1 by A, inverse of this value. But in logical gates or in the Boolean algebra, inverse of anything that can be represented by putting a bar over it. So that is known as the inverse of A. So this is the inverse of A. And when we are using this, so that means that is the inverse of A and B, which is equals to, in mathematically we can write this is equals to B inverse and A inverse. So this is the known as the logical operations which are used in the Boolean system. Now next is the truth table. So what is the meaning of truth table? Basically truth table, that is a table which is used to represent the output of the these Boolean expressions which are used over here. So the output value that is represented over here, the truth table, that is a table that gives us all the possible value of the logical variables. That is a combination of and the combination of variables. That means, so in this case when the logical operation plus is applied, if for example on the A and in the B, in both of them we are giving the output is there, input 1 is given there. So 1, when the plus is there, now in mathematical terms 1 plus 1 that is equals to 2. But in the Boolean algebra 1 plus 1 that is equals to 1 always. That means when there is a signal in the A port, signal in the B port, in the output we are getting the signal. So mathematically 1 plus 1 that is equals to 2, but in the Boolean algebra 1 plus 1 means that is equals to 1 only. So that means there is a positive overlapping between the two signals. So means when the light is there on the one port, light is there on the B port, in the output if it is represented by C, so that means we are getting a light in the C port also. So that is that represent the output of both. The light is not get enhanced, but mathematically 1 plus 1 that is equals to 2. So the output values which are represented over here, the one table is maintained, that is known as truth table. Now in the second one, when the input is given to the A and there is no input in the B. So there is no input, but in the we will get the output on the C port. Again, when there is no input in both of them and there is no light in the output one. Now the table which is formed over here, which represent the resultant of these Boolean variables or the logical operations. So that table is known as a truth table. So that means with the truth table, we can represent the output value of the different logical operations which are applied to the inputs of the Boolean system or the binary system. So here the only two binary system is two variables are given over here. So depending upon the operation over here, we can get the output or the input value. Now depending upon these operations between the two variables, we can also define the different gates over here. That gates are known as the logic gates. So now this is a truth table. So depending upon these two values, That means 1 plus 1 that is equals to 1. So depending upon these values, we can define the different gates that can be defined, and that gates depends upon the logical operation. So that's why that gates are known as the logic gates. So this is known as the truth table. So that means the truth table, that is a table that gives all the possible values of the logical variables, and that is a combination of variables. So combination of variable means either it can give us the one value. For example, in case of NOR gate, when only inverse values are given. So in that case, the output value that can be given like this. So when this is the output of any signal. So that means when output is like this, so in that case, we are not giving us here the combination of variables are not there. Only by using a single variable, we can get the output value. So that means depending upon these values, the different tables, truth table that can be designed, and that can be implemented in order to convert the analog signals to the digital signals. It is possible to convert the Boolean equation into the truth table. So Boolean equation that can be converted into truth table. The number of rows in the truth table, that should be equal to 2 raised to power n. What is n here? N is a number of variable in the equation. So that here n is a number of variable in the equation, and 2 raised to power n, that what is n over here? N is a number of variables in the equation, and the number of rows in the truth table, that is equal to 2 raised to power n. That means in the table there are rows and columns are there. So what are the rows? So row number that is equal to 2 raised to power n, and n that is equal to number of columns. So by using this, we can maintain a truth table to the any given Boolean function. Now for example, if the Boolean equation consists of 3 variables, then the number of rows that will be 8, 2 raised to power 3, 8. And then what will be the number of columns? The number of columns that will be equals to 3. So that means in the Boolean expression, the truth table, the number of rows that is equals to 2 raised to power n, and the number of columns that is equals to n. For example, if there are, what is n here? These are the number of variables also. If the variable is 1, now 2 raised to power n or 1, that is equals to 2. So that means in the truth table, the column that will be 1 and the row that will be 2. So that is the truth table for the expression, or for the NOR gate is like this, or the NOT gate is like this. In that case, 2 raised to power 1, that means the number of variables, or that is equals to number of columns. So number of columns that will be equals to 1 over here. So this is the column over here, and 2 raised to power 1 that is equals to 2, that means rows that will be 2. So that is the representation of the truth table. Till now we have understood what are the analog and the digital signals, how we can convert the analog signals to the digital signals, and the Boolean algebra and the different terminologies, they get used to convert the output value in the form of truth tables. Now we will next part we can understand how we can implement this in the form of gates. Thank you.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.